Geometry students, welcome to your 10.3 notes about arcs and chords. So points on a circle determine both chords and arcs, and several properties are related to points on a circle. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Alright, so in this circle O that we're discussing, we can say that arc RS is congruent to arc TV if and only if line segment RS is congruent to line segment TV. Alright, so we're going to show you how to use that today. So if I've got a circle K, okay, so in this example, in circle K, arc AB is congruent to arc CD. So we've stated that those two arcs are congruent in circle K. And then it tells us to find AB. So it wants us to find what 8x is actually equal to. So we're going to use the fact that we understand that if these two arcs are congruent, then these two chords are going to be congruent as well. So we can go ahead and state that these two chords are congruent. And so we can say that 2x plus 3 is equal to 8x. And then we can use our algebra skills to go ahead and solve for x. So we get 3 is equal to 6x. And then we can use the division property of equality and divide both sides by 6 and get x is equal to 1/2. Okay? So it didn't tell us to just solve for x. A lot of us like to stop right there once we have an answer to something. We need to go ahead and substitute x back in to find out what the chord AB is equal to. So 8 multiplied by x, which we know to be 1/2, is equal to 4. So AB, the chord AB, or the line segment AB, is equal to 4.
Alright guys, so I've had to trim this video down a couple of times. So what I'm going to do on these problems here is I'm going to do the 3 that I have selected, and then I'm going to leave the other ones for you guys to do for practice. So I've got chord AC is congruent to chord AB according to the length of measure that they gave me here. So I know that 360 minus 90 degrees is going to be equal to 2x. All right, or actually let me say this a little differently. I can say 360 degrees is going to be equal to 2x plus 90 degrees. I can subtract 90 on both sides. Okay, I'll end up with 270 degrees is equal to 2x. Then I can go ahead and divide both sides by 2, and I would get x is equal to 135 degrees for number 4. Okay, so let's move on and go ahead and do number 8 here. So I've got the given information is that circle M is congruent to circle P. All right, so I've got circle M is congruent to circle P. And they told us in the definition of what was going on with these arcs that if I have two congruent circles, then I have a situation where if I have congruent arc lengths, then my chords will also be congruent if and only if. So I've got these situations going on here where 6x, which is the chord from circle M, is congruent to 2x plus 24. All right, and then I can solve for x using my algebra skills, and I would end up with 4x is equal to 24, and I can divide both sides by 4, and I would get x is equal to 6. All right, so let's move on to number 9. Number 9 has a similar type of situation. We've got circle V is congruent to circle W. All right, that's the given information for these two circles. And I have a arc here that is 162 degrees. Well, if I take 360 degrees and I subtract 198 degrees, I end up with 162 degrees. So that makes this arc congruent to the arc, I should say, the arc of TU is congruent to the arc of YZ. So if that's the case, then my chords here are congruent. And I can say that 9x minus 78 is equal to 3x. And then I can use algebra skills to isolate my variable. And I would get that, let's see, 6x is equal to 78. If I divide both sides by 6, I would get x is equal to 13.
YouTube gives me some limitations on time, so I need to get this page done in less than 2.5 minutes. So everything up here, I'm going to have you guys go ahead and read on your own. All right, so in circle O, line segment CD is perpendicular to line segment OE, and OD is 15 and CD is 24. Find OE. A diameter or radius perpendicular to a chord bisects the chord. So ED is half of CD. So ED is equal to 12. Okay? So knowing that information, what we're going to do is we're going to use the Pythagorean theorem to go ahead and solve and figure out what the distance between O and E is. So if I square 12, I would get 144. If I square 15, I would get 225. Then I can subtract 144 on each side of my equation using the subtraction property of equality, and I would get that this OE squared is equivalent to 81. I can take the square root of both sides, and I would get OE is equal to 9. All right, so I have limited time to explain how to do this exercise, so I went ahead and gave you that RT is equal to 12. And what I'm going to do is I'm going to go ahead and explain this. They gave us the radius of this circle. PQ is the radius because they told us that it's circle P, which gives us that the P is the center of the circle. And so that tells me that PQ is the radius. Well, if PQ is the radius, then I also know that PR is going to be the radius as well. So that's going to be equal to 13. So this line segment here, and I'm going to go ahead and zoom in, and I'm going to show you that this line segment here is also a radius, and it is equal to 13. So I can use the Pythagorean theorem then to determine what the length of PT is going to be. So what I'd like you to go ahead and do is pause the video, see if you can find the value of PT, and then we'll unpause the video and fact check. So I went ahead and found PT for you, and I also went ahead and found TQ for you.
Okay, so the given information on number 4 is that the measure of arc length CD is equal to 90. So that means that the measure of DE is going to be half of that. So the measure of DE is going to be 45. In addition, the measure of FD, the line segment FD, is going to be half of the measure of CD. So that's going to be 8. In the interest of time, I'm going to have you guys go ahead and work number 6 as part of your practice. I did include a couple of the side lengths for you based on my analysis, so you should be able to use the Pythagorean theorem along with your example that we did in those other exercises there with a right triangle so that you can figure out what the length of FE would be, or AF would be. All right, so in number 8, we have the given information here. And based on the given information, what's going to end up happening is GQ is going to be congruent to QE. All right. All right, I did change QE to be EQ so that you guys wouldn't get confused since that is given information here. Sorry about that, but then I went ahead and solved for X, and I am out of time. We will see.